All right, welcome to another fun-filled edition of Comet Algebra. This is for section 10.2, where we're going to learn to solve right triangles using the trig ratios. So when you know the sides of the triangle, and you want to calculate the degrees, we use the buttons that are called the inverse trig ratios to find these angles. The inverse sign in many books is also called the arc sign. I don't think your book uses that, but I wanted you to be aware of that terminology. And it looks like this on your calculator, the sign with the little inverse. The inverse cosine is also called the arc cosine, and the inverse tangent is called the arc tangent. So here's what I mean when I say that you go backwards. In this example, we're asked to find angle B, right there. So we look what we're given. We're given the side that's across from B, which is called the opposite side, and we're given the hypotenuse. So we ask ourselves which trig function involves opposite and hypotenuse, and that would be the sine. So we write the sine of angle B is equal to 3/10. So here's what I mean when I call these things the opposite buttons. The backwards buttons. We want to go backwards. We know the ratio. We want to go backwards to find the degrees. So you use the backwards key, the sine inverse, punch that key, and then enter the ratio, 3/10, hit enter, and your calc will give you the degrees. I'm going to round to the nearest tenth of a degree, so it's about 17.5 degrees. Now the other thing you need to know here is when the directions say solve the triangle, what that means is that you need to find all the sides and all the angles. You need to find everything. So please make a note of that. Solve the triangle means find everything. We're asked to solve triangle ABC. That means we have to find this missing side and we have to find both acute angles. You can do this so many different ways. You can start wherever you like. I guess I'll start with finding the hypotenuse. We could use trig to find it, or we could use Pythagorean theorem. Again, whatever your preference is. If you'd like to square both of the legs, add them, and take the square root of them, I got that the hypotenuse is 8.1. I should say about 8.1 because I rounded off. Now we need to find both these angles. Again, you can use a variety of strategies. I guess I'll find angle A first, and I'm given, well, we have all the sides, but we could use the side opposite is 4, the side adjacent is 7, and those two sides would be in the tangent function. So the tangent of A is equal to 4/7. Okay, I'm going to need that backwards key to go backwards to find the degrees. So I hit inverse tangent of 4/7. And again, rounding to the nearest tenth, 29.7 degrees. Now you can use trig to find angle B, or you could go back to the fact that you learned in geometry that the three angles in a triangle add up to 180. So you could just take 180, subtract your 90, and then subtract angle A, and find that angle B is 60.3 degrees. Now we have found everything, all three sides, we know all three angles, we have solved the triangle. For what we're doing next, and when we study the unit circle, your life's going to be so much easier if you memorize these special triangles. And if you don't memorize them, you need to know how to build them using your knowledge and logic, which you can do. So first, a 45-45-90 triangle. We know that this is isosceles because the two angles are equal, so we know the two legs have to be the same. If this one's x, the other one's x. And then to find the hypotenuse, it's the leg times the square root of 2. And if we forget that, we can put in 1, like a unit triangle, and then use Pythagorean theorem, 1 squared plus 1 squared, 1 plus 1 is 2, so we have the square root of 2. So we can build this. So therefore, anytime you have the leg, you just take that times the square root of 2, and you have the hypotenuse. The tricky part of this one, and it's not that bad, is when you're given the hypotenuse, and you kind of have to go backwards. Let's say this is B, and if we multiplied by the square root of 2 to get the hypotenuse, if we're going backwards from the hypotenuse to the leg, we would divide by the square root of 2. And then we need to rationalize the denominator. So multiply by square root 2 over itself, and we would get B square root 2 over 2. And of course, both legs would be the same. Now looking at the 30, 60, 90, you could also build this, if you don't have it memorized, by looking at where it came from. Recall what an equilateral triangle looks like. All 3 sides are the same. All 3 angles are 60-degree angles. If I were to cut this in half, oh, nice job there, we would form a triangle that has a 60-degree here, a 90 here, and a 30 up here. And this hypotenuse is the same length as this side, which I just cut in half. That's why this side, which I will call the short leg is the leg across from the small angle, the 30. The long leg is this one across from the 60-degree angle. So because we cut this side in half, the short leg is always half the hypotenuse in a 30, 60, 90. That's why this says x, and this is twice that, or 2x. Here in my other example with numbers, if this short leg is 1, the hypotenuse is twice that, or 2. And then to get to the long leg, it is the short leg times the square root of 3. And again, if you forgot that, you could use Pythagoras down here. 2 squared is 4. 4 take away 1 is 3. Therefore, the long leg is the square root of 3. It's the short leg times the square root of 3, and 1 times square root of 3 is square root of 3. So if you're given the short leg, you would double it to find the hypotenuse, and you would times it by the square root of 3 to get the long leg. The tricky one with these is if we were given the long leg. Let's say they gave us this long leg and they said this is y, whatever that number is. Well, if you go from the short leg to the long leg and you multiply by square root 3, when you would come and have the long leg and go to the short leg, we would be dividing by square root 3. And again, rationalizing the denominator. I would have y square root 3 over 3. To go from the short leg to the hypotenuse, we double it. So it would just be 2 times whatever this is. 2y square root 3 over 3. So let's try a couple of these. When asked to solve the triangle here, the advantage to knowing these special cases is that it saves you a ton of work. You could use trig here to find the other 2 sides, because we know this third angle is also 45. Or, if you remember the special cases, if you know that the leg times the square root of 2 gives you the hypotenuse, and we go backwards, we take the hypotenuse and divide by the square root 2 to find the leg, then all you have to do is rationalize the denominator. And we have found that 5 square root 2 over 2 is this leg and this leg. And we have solved the triangle. Likewise, your work is so much easier here. If this is a 30, we know this is a 60. We need to find the other 2 sides. If the short leg is 8, we double that to find the hypotenuse. Hypotenuse is 16. And then to find the long leg, we multiply by square root 3. And that's it. You're done. No trig. So please do memorize or know how to build the special case triangles. Now we need to define two terms. One is the angle of elevation, the other the angle of depression. These two definitions are exactly the same except for the word above and below. The angle of elevation, shown in red, is an angle formed above a horizontal. An angle of depression is an angle formed below a horizontal. Now, a horizontal can exist anywhere. It could be the ground in a problem. It could be the surface of the water. It could just be straight out from the person or a lighthouse line of sight or whatever, straight out from the top of the building. So the horizontal can exist anywhere, and the angle of elevation is above it, angle of depression is below it. I recommend that for every single one of these word problems that you do, draw a picture. You simply cannot see the triangle or what trig function to use or anything unless you draw a picture. So in this example, a roof has an 8/12 pitch, meaning that for every 12 inches of run, it is rising 8 inches. So I try to draw my picture sort of in relation. So if this is a 12 inch, here's my right angle, we have an 8-inch rise. We want to find the roof's angle of elevation. So the angle of elevation is above the horizontal. So I'll just call this angle A. And to find angle A, we look at the sides that we're given to work with. We have opposite and adjacent, so we know we have to use the tangent function. So the tangent of A is 8/12. Use the backwards key on your calc. We're going backwards to find the degrees. So you hit inverse tangent, 8 divided by 12. And if I did this right, and I'm going to round off to the nearest degree, angle A is approximately 34 degrees. All right, in this last example, we are standing 75 feet away from the base of a building, and we're looking through a transit, which is like a tool, kind of like a telescope they look through to measure angles and distances. So the transit is 5 feet off the ground, and we are 75 feet away from the building. So the horizontal is not on the ground this time. It's up here, 5 feet above the ground. And we have used the transit to measure the angle of elevation to the top of the building here. This angle is 67 degrees. And what we're looking for is the complete height of the building here. That's our end goal. But we have the triangle over here to work with, this being our 90. So we need to find this leg of the triangle. I'll just call it B here for a moment. We need to find this B. After we find it, we will add on this 5 feet, and then we'll find the complete height of the building. So looking at the 67-degree angle, I'm looking for B. I know that I am standing 75 feet away from the building, so those are the two values that I use. And opposite and adjacent is tangent. So if I know the tangent of 67 is B over 75, now I need to use my algebra to solve this. So do the tangent of 67 in your calc, get the decimal number, and then we multiply both sides by 75. And if I did this correctly, B is approximately equal to 176.7 feet. But remember, we have to add on the height of the transit. So if you add on the 5 feet, the total height of the building is 181.7 feet. All right, that concludes section 10.2. Have fun.